Good afternoon, everyone. My name is Hilda, and I'm from Group 39. I would like to take you through our project, which is AgriAi, and our target customers are smallholder farmers in Uganda, extension officers, and rural cooperatives. So the core problem is that Ugandan smallholder farmers lose yields to soil issues like acidity and nutrient gaps. They lack affordable, evidence-based crop advice, leading to failed seasons. So the major problem Ugandan farmers are facing is not lack of effort or low effort, is that they lack the knowledge. This leads to failed seasons and low incomes. So if the farmer is not aware of their soil nutrient capacity, for example, the pH in the soil, the potassium, the zinc contents and everything, the acidity of the soil, the content of the organic matter in the soil, the farmer is likely to choose a crop that doesn't go with the soil nutrients that his or her land has. The most affected group here are smallholder farmers and stakeholders like extension officers. These try to help the smallholder farmers. So why is AI essential here? First of all, the basic apps can't handle complex farming relationships. For example, that acidic soil kills maize, but it grows this. And the regular AI chatbots make up wrong answers. Most of the AI chatbots hallucinate answers, and this may lead to low yields for the farmer, may cause trouble for the farmer. And our AI is a graph-based AI that is learning from real Ugandan farming experts. We use real Ugandan data. So it understands relationships like acidic soil kills maize but grows cassava, or plant beans after maize to restore soil health. This is real knowledge. It is not guessing. It has learned using the Ugandan data that is available. And the measurable impact that we can get from this is high increase in yields. There will be reduced hunger strikes via a high expert match accuracy. For example, in parts of Karamoja, the northern part of Uganda, most of them are facing hunger strikes, basically because of their low yields, and these low yields are caused by the lack of this knowledge. So if they're able to follow or use our AI and follow its recommendations and guidelines and the implementation plans, they will be able to reduce the hunger strikes since they are planting crops that are matching their soil content. There will be reduced input waste since exact input required is recommended. So the waste of the inputs will be reduced since these farmers are recommended the soil input to add. For example, add lime, add phosphorus, add lime to increase pH. So the farmer uses the input that is really required for their soil. So that will reduce the input waste. Then it will empower women-led farms since it does not require much expertise now. So there is not much expertise needed if the person is able to input their soil data within the AI. This makes it easier for the women who do not have much of the expertise in the farming side. The primary users are the smallholder farmers. Then the secondary stakeholders are the National Agro-Advisory Services, and this is an agriculture extension body. There are non-government organizations, rural banks mainly located. There are non-government organizations, for example, BRAC, that is helping women and men, but in the rural areas to develop their agriculture. Rural banks, for example, Mamedicot, that is helping these farmers with the money, the loans, and the advice. Then the ecosystem roles are the data suppliers. We got our data from FAO. We downloaded the datasets from FAO. We had Ugandan bulletins, and these were the PDFs that we downloaded from sites like ResearchGate. We have API consumers, and these are the cooperation dashboards for district insights. The algorithm designers are our team fine-tuning the large language model. The platform maintainers, this is an open source repo with community folks. The government entities, ANITA and farmer corporations. The data sources and value. The data types we had were tabular data, and those were the CSV files that we had. And these had the soil data that contained the pH, the NPK, the organic matter. We had text, and those were the PDFs we downloaded from sites like ResearchGate. We had geospatial data that contained the agroecological zones and the rainfall data. We have sources like FAO taxonomies, Uganda extension PDFs, and here we use the PDF plumber for the extraction. And our processing pipeline, we had the data collection, and that was the PDF mining. We had to go through a lot of PDFs to determine which PDF was most suitable to use. We had the data cleaning, and that was searching for the missing values, the data imbalances, and what we had the annotation, we had the validation and the storage. Then the ethical and logical framework, that's the Ugandan Data Protection Act of 2019 compliance. Then the value mechanism, we created knowledge graph that drives 78% accuracy, and this is enabling trust-based recommendations. Social value, social value, it yields boosts, and commercial value, it is licensed to corporations for scaled insight. Since according to our PDFs, we had a lot of PDFs that were including the economical value, so that our recommendations are focusing on the economic system of Uganda, so that they are within the farmers' economic range. The AI methods we used were relational graph convolutional network with knowledge graph embeddings, distilled GPT-2 with RAG. The inputs of our AI are that there is pH, organic matter, soil texture, nitrogen, phosphorus, potassium. There is weather data, which includes the temperature and the rainfall and the available land that the farmer has. Then the outputs, we have the priority actions, the suitability score, the AI analysis, expert analysis, technical analysis, implementation plan, and land allocation plan. Then there are subgraph retrieval grounds, that subgraph retrieval grounds, large language models and roles. Constrained decoding enforces no violations. Then planner optimizes rotations under resources. And then the integration is an Android app and APIs for cooperation dashboards. So the key metrics and evaluation. How smart is our AI? First of all, our advice is 78% correct most of the time. Then we have a high suitability accuracy basing on the farmer's data, and we have 0% bad advice or rule violations. Since we are following majorly, we are measuring on Uganda and concentrating on Uganda, and we are using the data sets of Uganda. So our farmers actually using it. So we check the adoption rate and how long people stay on the app and how happy our farmers are. Is our advice fair? We ensure fairness for all regions and genders, so keeping the bias very less. And our advice is very easy to understand making it very transparent. We are using simple English for the advice. And there is fairness for origins, since origins are considered according to our data, keeping the bias very less. And is it a good business? We make sure the costs, we measure the cost to get a customer, the long-term value they bring, and our return on AI investment, the unfair advantage and differentiation. So we have various pieces of local farming data collected from different Ugandan sources, and this is a unique knowledge base. This unique knowledge base is hard for others to copy. We can't all have the same data, so this is very hard to get. Our system does not lie because it combines knowledge graph with strict farming rules, so it will never give bad advice for the farmers. And our fine-tuned AI brain is a special intellectual property asset. The other thing is that we shall update crop advice every after a while whenever the FAO releases new data, and we keep making the app better by adding features farmers ask for example, the voice input, since some of the farmers may not know how to type or how to read the English. So we keep making the app better so that we can add an option of sending a voice note to the whereby the farmer sends a voice note to the app and they are replied with a voice message too in that particular language that they are using. And the system is designed for people with basic phones, low literacy, and focuses on low interest. So basic phones may include like the ITEL phones and what, since not all people have the strong powered phones, and our system is designed for people with these basic phones since we are using the digital GPT-2. Then low literacy and focuses on low internet costs. Our system can handle many farmers and it automatically scales up during busy planting seasons. Channels and distribution are the acquisition channels for our AI will include the National Agri Advisor Service workshops, WhatsApp farmer groups, since most of the farmers have WhatsApp groups for their communication. Then we have the SEO on Ugandan soil crop advice, and we have the cooperation referrals. The delivery channels through the Android app, the web dashboard for officers, WhatsApp bot for quick checks. The partnerships include collaboration with universities, for example, Makerere University, the non-governmental organizations, for example, BRAC Uganda, and digital literacy campaigns. The retention tactics include the community forums in app. Then the revenue streams, cooperatives have to pay a small monthly fee to keep using the advanced tools and get scaled insights. Licensing fees, big organizations or companies pay us to use our special AI farming knowledge. Pay per use, other systems can pay us a small amount for every piece of specific instant advice they get from our AI. Then data as a service, we get paid to share general farming trends, not personal secrets, with rural banks and non-governmental organizations. Then basic advice for farmers is free, but custom analysis or premium dashboards require a fee. The key resources, the human resources include the AI engineers, the machine learning researchers, the data scientists, the UX designers, ethicists, and policy experts. The technical infrastructure include the cloud storage, the computing power, the CIDOC pipelines, and MLOps tools. The data infrastructure includes the data lakes, the APIs, annotation tools, labeling teams. The organizational resources include the research partnerships, legal teams, IP protection units, and communication channels. Then the financial resources include seed funding, grants, venture capital, strategic partnerships. The key activities are keeping our AI smart. So we update crop advice every 3 months when FAO releases new data, and we retrain our system monthly using real farmer feedback. Then we could add features farmers ask for, like the offline mode for in areas that do not have a very good internet, and voice input in Uganda or any other language for farmers that do not know how to type or may not know English. Then we build dashboards that cooperatives can actually use. Then we check that our advice stays accurate, we keep the farmer data safe and secure, and we make sure the app works 99% of the time. So we check twice a year that our AI treats all farmers fairly. We follow Uganda's data protection laws. Then we run WhatsApp groups where farmers can ask questions. We train extension farmers monthly so that they're able to use our AI effectively, and we listen to feedback and improve. Then the key partners, the technology partners include the cloud service providers, the API platforms, the AI research labs, Hugging Face, Hugging Face that was our AI model. We have data partners like FAO for the crop information, the Ministry of Agriculture for the soil data, and Macquarie University for the research validation. We have ethical oversight partners that include the NITAU, that checks we follow data laws, the farmer cooperatives, for example, the BRAC, the Mamedico, that make sure we serve farmers well. Then the distribution partners, for example, the MTN and Airtel, or Laika, these help farmers access us via WhatsApp. BRAC Uganda that reaches to remote villages, and community radio stations that spread the word. Then group members that contributed the funds to accomplish the project. Then the cost structure, the data costs, collecting, organizing farming knowledge, then running the AI and storing data. Then the team's salaries include the engineers, data scientists, and farming experts. Then legal and compliance, following data protection laws. Radio ads, marketing include radio ads, workshops, printed materials for farmers. Then updates and maintenance include keeping everything working smoothly. So who oversees us? A board of farmers, one extension officer, and 2 engineers that review our work every 3 months. We make sure women farmers get the same quality advice as men, and we check all regions of Uganda are served equally. Farmers can see exactly why we recommend certain crops. We explain which soil factors mattered most, and everything is in simple English. Then we comply with Uganda's Data Protection Act, and farmers sign consent forms knowing how much we use their data. Then extension officers review risky recommendations, and farmers can dispute advice they don't trust. So we publish quarterly reports on our accuracy. Then our system can handle many farmers without breaking. Then we learn from every farmer who uses us. Successful harvest teach our AI what works, and we test improvements carefully before rolling them out. Then reaching more people, this will include adding more local languages, Igi, Runyankore, then building voice features for farmers who can't read, and adapting advice for different regions of Uganda. For example, if you're to recommend a crop in the western part of Uganda, the hilly areas, we could add more advice like the terracing of the land, the method of farming, the method of irrigation for the northern part of Uganda. so this could reach out to more people. Then our AI is small and energy efficient. We recommend less fertilizer, which is reducing pollution to the soil. Then we promote crop rotation for healthier soil. Then our app works offline for 30 days. Then backup systems if servers fail. Then multiple partners so we don't depend on just one organization. So what makes our AI unique and protectable? Ugandan farming knowledge base. We have over 1,000 pieces of local farming wisdom we have collected from different Ugandan sources. And our systems do not lie because it combines knowledge graph data with strict farming rules, so it never gives bad advice. It works for real farmers since it's designed for people with basic phones, low literacy, and less internet costs. How do we protect it? App code is open source and it's free for community benefit. These are our contributions. Thank you so much. And you could reach out for more inquiries about our AI system.